All right, so you guys sent us something pretty interesting this time.
Yeah.
It's a file called random.pdf.
Uh-huh.
And I gotta say, the name is pretty accurate.
It is.
We're looking at pages and pages of what appears to be complete gibberish.
Right.
Just letters and numbers.
Yeah.
No spaces, no punctuation.
Yeah, it's certainly intriguing, isn't it?
Oh, yeah.
Reminds me of those classic cryptography puzzles, you know? The
Oh,
ones
right.
where you're staring at a wall of what seem to be totally random characters.
Yeah.
Just wondering if there's a hidden message
Right.
hiding in plain sight.
Exactly. And that is exactly what we're going to try to figure out today.
Okay.
Is this digital noise or is there something more to it?
Yeah.
I mean, it wouldn't be a very exciting deep dive if it were truly random.
Well, it depends.
Okay.
True randomness is actually harder to achieve than you might think.
Okay.
And it has some really fascinating applications in fields like cryptography and computer simulations. But before we get ahead of ourselves, let's start by taking a closer look at what we have.
Right.
You said it's all lowercase letters and numbers, right?
Yep.
No spaces or punctuation.
Nope. Just a jumbled mess as far as I can tell.
Huh.
I even tried running it through a word processor, just in case there were some hidden characters or formatting. But no,
Nothing.
nothing.
Interesting.
Yeah.
Okay, well, one of the first things that cryptographers often do
Yeah.
when they encounter something like this
Right.
is they do something called frequency analysis.
Okay.
It's based on the idea that in any given language, certain letters appear more often than others.
Oh, right, right.
So, for example, in English, E is the most common letter, followed by T, A, and so on.
So if we see a lot of QS or Zs in this file,
Mm-hmm.
that might be a red flag that something is up.
Exactly. It could suggest that the characters have been shifted or
Yeah.
substituted in some way.
Okay.
Let's actually try a quick analysis
Yeah.
on a small snippet from the file that you sent.
Okay.
Do you have it handy?
Let me see. Okay, here's a string from page 3. 2K7V9, a 3A0.
Okay.
And it goes on like that for a while.
Okay, so even in the short string, we see more numbers than we'd expect in normal English text.
Right.
And notice how there are no repeating sequences,
Oh, yeah.
at least not in this snippet.
Good.
So that could be another hint that we're dealing with something other than plain text.
Okay, this is getting interesting.
Yeah.
So frequency analysis could help us figure out if we're dealing with a simple substitution cipher, right?
Yeah.
Where each letter or number has been replaced by a different one.
It's a possibility.
Okay.
But there are many other types of codes out there,
Right.
some far more complex.
Um,
If this file is using a more sophisticated encryption method, simple frequency analysis might not reveal much.
So what are our other options then?
Oh, I
Do we
know.
need to call in like the code breakers from the NSA?
Not just yet.
Okay.
There are other techniques we can use to analyze the structure and randomness of the data. One is called entropy.
Entropy, okay.
Essentially, entropy measures the unpredictability of a sequence.
Yeah.
So imagine a coin toss. If it's a fair coin, each toss is equally likely to be heads or tails.
Right.
That's high entropy because the outcome is unpredictable.
Right. Okay, that makes sense.
But if you have a rigged coin that always lands on heads,
Uh-huh.
that's low entropy because the outcome is certain.
Okay.
So if this random.pdf file has high entropy,
Yeah.
it would mean the characters are pretty unpredictable,
Right.
which would make it more likely to be truly random and not a code.
Okay, so high entropy could mean it's random.
Okay.
Or it could mean someone's gone to a lot of trouble to make it look random.
Yeah.
So what else can we look at?
Another useful measure is compression ratio.
Compression ratio, okay.
This tells us how much a file can be compressed without losing any information.
Okay.
So if a file is highly compressible,
Yeah.
it means there are repeating patterns or structures within the data.
So a high compression ratio would suggest it's not truly random.
Exactly.
Oh, yeah.
It would indicate some kind of order or pattern within the sequence,
Right.
which could be a sign of a code or an underlying algorithm used to generate the data.
Mm-hmm.
On the other hand, if we find that random.pdf is practically incompressible,
Uh-huh.
then the case for true randomness becomes stronger.
Okay, I'm starting to see how this is like a digital detective game.
Yes.
We're looking for clues in the way that the characters are arranged, the frequency,
Right.
the entropy, the compressibility.
Precisely.
It's
We're
fascinating.
using the tools of mathematics and computer science
Mhm.
to try to, you could say, crack the code.
Right, right.
And while we're at it,
Yeah,
there's another avenue we could explore,
okay.
one that might seem a bit out there at first.
Okay, I'm all ears. Hit me with it.
What if we're thinking about this entirely the wrong way?
Okay.
What if this isn't about decoding a message at all?
Uh,
What if instead it's about the very act of decoding itself?
Hold on.
Yeah.
I need to wrap my head around that.
Sure.
You're saying it's not a message,
Yeah.
but a commentary on how we try to find meaning.
Think about it.
Okay.
Our brains are wired to look for patterns, for order, for meaning.
Yeah.
When we encounter something that seems random,
Uh-huh.
our instinct is to try to impose order on it, to decipher it,
Right.
to decode it.
But what if that's the whole point?
Yeah.
What if the creator of this file
Right.
is deliberately playing with our need to make sense of things?
It's a very interesting thought.
Yeah.
We're so used to thinking of information as something to be decoded.
Right.
But what if the real message is the lack of a message?
Whoa, that's deep.
Yeah.
So by trying to crack this code, we're actually falling into a trap.
It's a possibility.
Wow.
And it raises some interesting questions about the nature of information, meaning, and interpretation.
Right.
But let's not get too far ahead of ourselves here.
Okay.
We still got a lot to unpack.
Yeah. All right, so we've got our code-breaking tools.
Yeah.
We've got our philosophical musings.
Right?
Where do we go from here?
Yeah.
How do we actually start making sense of this random.pdf?
Well, there are a few things we can do.
Okay.
First, it would be helpful to know more about the origins of the file.
Okay.
Where did it come from? Who created it?
Right.
Knowing the context could give us some valuable clues about its purpose.
Right, because if we knew it came from, like, a cryptography enthusiast,
Uh-huh.
that would lend more weight to the code theory.
Exactly.
Or if it turned out to be part of some, like, scientific experiment on randomness,
Yeah,
that would point us in a whole other direction.
absolutely. So finding the source of the file is our first order of business.
Okay.
And while we're at it,
Yeah.
we can start running those analyses that we talked about.
Okay.
Frequency analysis,
Uh-huh.
entropy calculations, compression tests.
Okay.
We'll see what those reveal about the structure
Yeah.
or lack thereof of the data.
Okay, so we've got a plan.
We do.
Time to put on our detective hats and dig deeper into this random.pdf.
Let's do it.
Stay tuned, folks, because this deep dive is just getting started.
So while we're waiting to get more information on the origin of random.pdf,
Right.
I think it's worth trying to, apply some of the concepts we discussed.
Okay, yeah, sounds good.
Let's go back to entropy for a second.
Okay.
Remember, it's a measure of randomness or unpredictability.
Mm-hmm.
A coin toss with a 50-50 chance of heads or tails
Right.
has high entropy.
Yep.
A rigged coin that always lands on heads
Right.
that has low entropy because the outcome is certain.
Right, I remember, but how do we actually calculate the entropy of a file?
Right.
It's not like we're flipping coins here.
True, but the principle is similar.
Right.
We can look at the frequency of each character in the file
Uh-huh.
and use a formula to calculate a numerical value for its entropy.
Okay.
A higher value indicates more randomness,
Right.
while a lower value suggests more order. Okay. Or predictability.
So if we find that random.pdf has very high entropy,
Yeah.
does that mean it's game over for the code theory?
Not necessarily,
Okay.
as I mentioned before.
Yeah.
Some codes are designed to mimic the statistical properties of random data,
Yeah.
but high entropy would certainly make us question whether it's a simple code.
Okay, I'm seeing how this is getting more complex
Yes,
than just looking for patterns with the naked eye.
it is.
We need to bring in, like, the big guns
Yes.
of math and statistics.
Exactly. And that brings us to compression ratio.
Right.
This is another way to assess the randomness of a sequence.
Right?
If a file is highly compressible, it suggests
Yeah.
there are repeating patterns or structures within the data.
Right, right, because compression algorithms work
Exactly.
by finding those patterns
Yeah,
and representing them more efficiently.
right.
So if random.pdf can be, like, squished down to a much smaller size
Uh-huh.
without losing any information, that would mean it's not truly random.
Precisely.
Okay.
It would suggest that there's some underlying order
Hmm.
or redundancy in the sequence,
Right.
which could be a sign of a code or some other generating process.
I'm starting to think we need to run some tests on this file.
Yeah,
Do you have any software
I do.
that can calculate entropy and compression ratio?
Actually, there are many online tools and software libraries that can do that.
Okay.
We could even write a simple script ourselves if we wanted to.
Okay.
Yeah.
Well, I appreciate your enthusiasm for coding.
Sure.
I think for the sake of this deep dive,
Yeah.
we'll stick to the user-friendly tools.
Okay.
Maybe we can share some links in the show notes for listeners who want to
Yes.
experiment on their own.
Sounds good.
So once we run these tests,
Yeah.
what are we hoping to find?
Well, if we see low entropy and high compressibility, that would suggest there's some structure to the data, which might make us suspect a code or some other non-random process.
Okay.
On the other hand,
Yeah.
if we see high entropy and low compressibility, that would lend more weight to the idea that it's truly random data.
Okay. And of course, there's always the possibility of something in between.
Absolutely.
Right.
It's rare to find perfect randomness or perfect order in the real world.
True.
Most things fall somewhere on a spectrum.
Okay, so we're looking for clues.
Yeah.
But we're also keeping an open mind.
Absolutely.
And while we're waiting for those test results,
Yes.
let's not forget about the other angle we discussed.
Right.
The possibility that this file is more about the act of decoding itself than about a specific message.
The idea that it's a commentary on our need to find meaning.
Yeah.
Even in the face of apparent meaninglessness.
I have to admit, I'm still struggling with that concept.
Sure.
It just seems so counterintuitive.
Yeah.
Why would someone create something that's intentionally meaningless?
Yeah. Well, consider the history of art.
Okay.
Think about abstract expressionism, Dadaism, and other movements that challenge traditional notions of representation and meaning.
Right.
These artists were often more interested in exploring the nature of perception, the subconscious, and the creative process itself.
Okay, I see your point.
Yeah.
But those were visual art forms.
Right.
This is just a text file.
Yeah.
How can you convey those kinds of ideas through, like, a jumble of characters?
Well, think about it this way.
Okay.
The very act of trying to decode random.pdf to find a message where there might not be one could be seen as a performance.
Oh.
A kind of interactive art experience.
So the meaning isn't in the file itself.
Yeah.
But in our reaction to it.
Exactly.
In the mental gymnastics we go through trying to make sense of it.
That's one interpretation.
Wow.
And it reminds us that meaning is not always inherent in the object itself, but often created in the mind of the observer.
This is definitely making me think about things in a new way.
Good.
I'm starting to appreciate the ambiguity
of
this whole situation.
It's ambiguous.
It's not just a black and white case of code or no code.
Right.
There are, like, layers here.
There are.
Different levels of interpretation.
Exactly. And that's what makes this deep dive so fascinating.
Yeah.
We're not just trying to solve a puzzle.
Right.
We're grappling with fundamental questions about information, meaning, and perception.
Okay. I'm ready to take this to the next level.
Okay.
Let's dive into some of the practical aspects of code breaking.
Okay.
What are some common techniques we could try applying to random.pdf?
Well, since simple frequency analysis might not be enough, we could explore other types of ciphers.
Okay.
One possibility is a transposition cipher, where the letters of the original message are rearranged according to a specific pattern or a key.
So instead of replacing letters with other letters or numbers, you're just shuffling them around.
Exactly.
Wouldn't that make it, like, incredibly difficult to decode?
It would.
Without knowing the pattern?
Absolutely.
Okay.
Transposition ciphers can be very secure if the key is kept secret. But there are techniques for analyzing the frequency of letter combinations and looking for statistical anomalies that might reveal clues about the transposition pattern.
So it's like a more advanced form of pattern recognition?
Yes.
Looking for subtle hints in the way the characters are arranged.
Exactly.
Okay. What other types of ciphers should we be aware of?
Another category is polyalphabetic substitution ciphers.
Okay.
These use multiple alphabets to encrypt the message.
Oh, wow.
Making frequency analysis much more difficult because a single letter can be represented by different symbols depending on its position in the text.
Wow. That sounds really complex.
It can be.
Is there any chance we could actually crack a code like that?
It depends. It depends on the complexity of the cipher and whether there are any weaknesses in its implementation.
Okay.
Some historical polyalphabetic ciphers, like the Vigenère cipher, have known vulnerabilities that can be exploited with the right techniques.
So even with these more sophisticated ciphers,
there's
still a chance we could break the code.
There is.
if we're clever enough.
Exactly.
Yeah.
Code breaking is a combination of logic, mathematics, pattern recognition, and sometimes a little bit of luck.
Okay, I'm feeling inspired. Let's roll up our sleeves
Right.
and start applying some of these code-breaking techniques to random.pdf.
Let's do it.
Who knows? Maybe we'll stumble upon the key to unlocking its secrets. Okay, so we've explored a lot of ground in this deep dive.
Yeah.
We've talked about frequency analysis, entropy, compression ratios, different types of ciphers. It's been a whirlwind tour of the world of code breaking.
It has.
And we've also delved into some more philosophical questions about the nature of information, meaning interpretation.
Yeah.
Right? Because even if we can't definitively crack the code of random.pdf, so to speak,
Right.
there's still a lot we can learn from the process of trying, right?
Absolutely.
It's making me think about how we approach information in general.
Yeah.
Not just mysterious text files.
Right. I think that's a key takeaway here. We live in a world awash in information. We're constantly bombarded with messages, data, stimuli.
It's true.
Learning to discern patterns, to separate signal from noise, is becoming increasingly important.
I totally agree. It's like we need to develop our own internal code-breaking skills just to navigate daily life.
Exactly. And that's where critical thinking comes in.
Right.
It's about asking questions, challenging assumptions, not taking things at face value, recognizing that meaning is often contextual and subjective, not always clear-cut or objective.
So even if random.pdf turns out to be nothing more than just like random string of characters, the process of, analyzing it, of trying to make sense of it, has been valuable.
It has.
In and of itself.
Absolutely. It's stretched our minds. It's forced us to think outside the box and maybe even challenge some of our preconceived notions about how we interpret the world around us.
I have to admit, I'm still a little bit obsessed with the mystery of it all. I keep finding myself going back to the file, staring at those characters.
I get it.
Hoping to see something I missed before.
I understand the feeling. There's something inherently intriguing about a puzzle. Especially one that resists easy answers.
Even if we never definitively solve this mystery, it sparked my curiosity about the wider world of codes and ciphers. I'm definitely going to be reading up on cryptography after this.
I encourage you to.
It's fascinating.
It is.
Well, on that note,
I
think it's time to wrap up this deep dive.
Okay.
We've explored a lot of possibilities.
We have.
Raised a lot of questions.
Right.
And maybe even learned a thing or two about ourselves along the way.
And who knows?
Right.
Maybe someone out there listening has the missing piece of the puzzle. The insight that will finally unlock the secrets of random.pdf.
If that's you, we want to hear from you.
Yes.
Share your theories, your insights, your wild speculations down in the comments below.
We'd love to hear them.
We're always up for a good code-breaking challenge.
Until next time.
Yeah.
Keep those minds sharp, those questions flowing. And remember, sometimes the most interesting discoveries are the ones we least expect.
And that's a wrap on this deep dive.
Thanks for listening, everyone.
Thanks for joining us. And keep exploring the world with curiosity and an open mind.